not long ago. Obviously, we're a great believer in the quantities and how it brings. We've really targeted a lean, green, and mean construction, rather than lean, mean fighting machine. You know, quantities are pretty key to what everyone does. I mean, we're all using them, we're all deriving them from models, we all measure them. Whether you're doing lean, whether you're the QS, someone somewhere is measuring. So, you know, we have many ways of doing that, and we go into the coordination processes, which most people are familiar with, you know, avoiding the clashes, so we can reduce the amount of clashes on a project, and therefore, if we reduce the amount of clashes, we can build faster and more efficiently, and use even more off-site construction. The coordination side of it in the rework will also avoid problems like that, where we all end up delaying handovers and doing a lot of making good and getting in a right old muddle. But from our perspective, from the solutions we work with and how we work, we allow you to bring in the models, as everyone is familiar with. We bring in the 2D data sets and we coordinate. There's still a lot of 2D work out there, there's awesome amount. But all this information is relevant, it all has multiple attributes, and it's all about drilling the attributes to follow that through. When we're working the cost structures, we actually incorporate embodied carbon values as well. So when you're calculating costs, you calculate carbon. Okay, and at the same time, we can also assign additional tags for life cycle. So from one view set, you're drilling across multiple platform data set. After all, BIM is all about coordination and collaboration. And you know, as we go through, obviously Russ picked up this and I thought it was quite appropriate to bring in the famous light bulb, about the amount of energy it burns compared to an LED light bulb. I'm not sure what's going on, it's going on its own at the moment. And the GreenBIM side of it, from our side of it, obviously you've got the cost, we link it to the objects, we link it to the takeoff, so wherever you are, whatever information you're drilling, we can view the data sets that are linked to all them attributes. It's making it a lot easier to track the information. And when we're value engineering, bearing in mind off-site, we can switch from, let's just say, casting situ on-site to precast. So we can literally switch between the two and see what's the best value of the project and the impact on program at the same time. If we go into the package management side of it, in here, in the package management side, we can link, everything links to packages. What we do differently is we actually find out the resource information we'd like people to price up, and also tell us where they're sourcing it from, because that has a big impact on carbon, embodied carbon, cost, and the most efficient way of construction. Like I said earlier, life cycle information is key, so we can start tagging the information. With how many years we don't have to do a repair, replace. So we start value engineering the project from a life cycle point of view. It's where most of the money is, most of the risk. At the same time is, we'll just come down one more, we've got the quantities and the scheduling. So if we can start bringing all the embodied carbon information, the life cycle data and the cost, we can start seeing how in the value engineering it will affect our program. The faster we can deliver the project, the more efficient we are, the quicker we're off, and the less carbon footprint we're leaving. At the same time, well, it's gone crazy there, sorry. Go back. Obviously, RFID tags, the ability most people are doing it to capture it from manufacturer, track it to the site and in, and you can time the durations on where the route was taken for the goods to get to site, and obviously where they're installed on site. So the key areas is, you know, we're out to reduce the time to construct, lower the environmental impact and durations, and then get to the project conclusion as quickly as possible in the fastest possible and safest route. So benchmarking, I heard someone just talking about benchmarking. We benchmark both value, cost and embodied carbon. Okay, so we can start seeing across projects where the carbon values are differently, where the cost is different. And you can start seeing what construction techniques were used as well, whether it's precast, cast in situ, whether it was off-site for the MEP or on-site. And then obviously, simple one, life cycle costing, picking on the old famous light bulb versus an LED light bulb. Simple, but you can reflect that right across the building portfolio. Types of paint, floor finishes, windows, doors, a lot. And what's the running, capex cost and the running cost? If you look at the life cycle, if you can bring that down, profile it better, get more efficient at it, you'll find more people will build more, and hopefully for the same, keep the budgets there rather than reduce the budgets. So, facilities management cost over a period of years. Everything's that route now. So when you're building something, you're looking at the life duration of the project, even if infrastructure projects we're involved in at the moment. And that goes right the way down to the gantries and everything on the roads, and then all back to a central repository so you can drill that data set. It does not all have to be in a model. It's linking data together. This is a key. That's what we're trying to get over. So from all this information being pulled together, you can start benchmarking, profiling, and tracking your projects. Thank you. I think we're there. Thank you very much.